Okay, let's do this. We're going to get into a piece of gear that really makes modern sports broadcasting possible. The Thor Broadcast SpiderSDIPro system.
It's one of those invisible technologies that's just mission critical.
Right. So our mission today is to unpack the magic. I mean, picture this. You're at an NFL game, camera on the 50-yard line, and the production truck is, what, half a mile away outside the stadium? How do you get that perfect shot back to the director?
Well, you definitely don't use traditional copper cable. That's the challenge. The distance, for one, would kill the signal quality.
From the interference, right?
Oh, absolutely. In a stadium with huge screens, radios, Wi-Fi everywhere, that electromagnetic interference would just turn your feed into static. Copper can't handle it.
So this is where the SpiderSDIPro comes in, and it's all about fiber optics. But it's not just any fiber connection. It delivers up to 12G SDI, which sounds impressive. What does that number actually mean for the broadcast?
That 12G SDI, that's the magic number. It's the amount of bandwidth you need to send a pristine, uncompressed 4K video signal at high frame rates.
Which is what you need for those super slow motion replays.
Exactly. And the way they push that much data up to 10 kilometers without a single relay is with a technology called CWDM.
CWDM. Okay, break that down. What is that in practice?
Think of it like a prism. Coarse wavelength division, multiplexing, CWDM, basically takes different signals, video, audio, Ethernet, comms, and puts each one onto its own color of laser light. All those different colors of light then travel down one single tiny strand of fiber at the same time. It massively multiplies what that one cable can carry.
So that one strand isn't just carrying the pretty picture. It's the entire nervous system for that camera operator.
It's the whole ecosystem. You have your main video feed, of course, meeting professional SMPTE standards, but you also have balanced XLR audio input.
For clean commentary and on-field sound.
Yeah, and it has this incredible 100 decibel signal-to-noise ratio. But I'd say most importantly, you have the comms in control.
The comms being the director in the operator's ear yelling, pan left, zoom in.
Precisely. That's a standard 3.5 millimeter intercom line. And then you have tally.
The little red light on the camera.
A little red light. It tells the operator you're live. And that signal has to come all the way from the truck in reverse instantly.
It's amazing. I was also struck by the hardware itself. The transmitter the camera op is using is tiny. It's like 2 pounds, right? And it just clips on with a V-port battery.
Right, and that's by design. The operator needs to be mobile, agile. They can't be lugging around some giant box.
But then the receiver is the complete opposite.
Total opposite. It's a heavy-duty 1RU rack-mounted box. It sits in the broadcast truck, runs on AC power, and it's all about stability and central management.
Okay, but if that camera is outside, near a giant metal light tower in a thunderstorm, is that fiber link safe? I read something about 3-level lightning protection.
That's essential, especially for the audio interface. That protection, up to 6 kV, stops a power surge from frying all the sensitive electronics. But resilience isn't just about lightning.
It's about the signal itself.
Exactly. Over a 10-kilometer run, you get something called jitter. It's tiny timing errors in the digital signal that can make the video choppy or unusable.
And how do they fix that?
Both the transmitter and the receiver have clock recovery functions built in. It basically rebuilds the signal's timing on each end, so what arrives at the truck is perfectly synchronized, like it just came from a camera 5 feet away.
That plus things like intelligent noise suppression on the audio, and it's all plug and play. No setup.
Zero debugging. It just works.
The network side is also really powerful. It supports gigabit Ethernet and something called jumbo frames. Why is that important?
Jumbo frames are all about efficiency. Your standard network packet is maybe 1,500 bytes. The system can handle packets or jumbo frames up to 900, 200, and 206 bytes.
Wow.
It means it can bundle huge amounts of data, not just video, but also complex network traffic and control signals, and push it all through at once without any lag.
So to pull it all together, the SpiderSDIPro takes all these different critical signals, 4K video, comms, control, data, and synthesizes them into one simple, incredibly reliable fiber link.
It makes an insanely complex job simple, at least on the surface.
Right.
I mean, think about that number again. A 9216 byte data packet. That packet is carrying a piece of a 4K video stream, audio, and the director's voice all at the same time over kilometers of glass fiber in real time. The level of engineering needed to make sure not a single one of those bytes gets dropped during a live Super Bowl broadcast. That's the real magic.